Alright, this is Mr. Gillum, and today we're going to start learning how to solve two-step equations. But before we do, let's take a little review about how I would like to algebraically solve one-step equations. And just a reminder, our inverses are addition and subtraction. If you see subtraction, we're going with addition. If you see multiplication, we're thinking division. And if you see division, we're thinking multiplication. All right, so as a review, we solved these one-steppers before. We think of it as a balance, and we want to see what the variable is, what it would have to be to make the equation balanced through the equal sign. And so sometimes we tried to do it with mental math, and Mr. Gillum probably sent your paper back and said, I would like you to use algebra. Well, today's going to be the first day where things get a little more complicated. It'll be more difficult to use mental math, and so that's why we were practicing with algebra on our papers. And so what we're going to start with here is I see that I have an x and I see a plus 3, and I know that in algebra use inverse operations to remove what you don't want from one side of the equal sign. And so because it says plus 3, I know the inverse of positive 3 is negative 3. I'm going to put a negative 3 on both sides. That'll keep it balanced. And so I know that 3 and negative 3 add together to equal 0. And x plus 0 is still x, so x must equal 1. All right, and in fact, we even checked our solutions with algebra, and if you didn't use algebra, I probably told you to try it again. So 1 plus 3 equals 4. I know that 1 plus 3 equals 4, and 4 equals 4. So yes, we did do the right thing. Okay, so there's your brief reminder of how I want you to algebraically check your solutions. And so since we've been doing these a while, we'll go through these other ones a little quicker. I see that I'm trying to get x by himself, and I see this minus 5 in the way. So I'm going to add 5 to both sides of the equal sign. That'll keep it balanced, and then that'll also allow me to see how much the variable is worth exactly. In this case, 7. Or if you see a variable on a fraction, and we know that fraction bar means divide, and divided by 3, if I had multiplied both of them by 3 on either side, then I know 3 over 1 will reduce the variable, is all that's left, and n must equal 18. And again, with the fractions, they're a little more confusing because it's easy to forget that a fraction bar means division, but you can always check your answer as well. If I think the answer is 18, I'll put it in there. 18 divided by 3 equals 6. I know that 6 equals 6, so yes, I know I got the correct answer. And then finally, of course, multiplication. The 4 and the m are held together with multiplication. Now we don't put that in there. We don't write that little dot or put the x in there all the time. But when they're squished together like that, that means they're being multiplied. So in this case, the inverse of multiplication would be division. And again, we're not using this sign anymore. We're using a fraction bar. Okay. So when I divide both sides by 4, I will have m equals 4. Or I can think of it, if I want to check my answer, 4 times 4 equals 16. 16 equals 16. I know that is true. Okay, so there's your review on one-steppers. Let's take a look at two-steppers now. And so the basic rule of thumb for two-step equations would be first add or subtract, and second multiply or divide. And there's a reason we do it in that order, and I'm going to show you why here in a second. I see now that our equation has gotten a little more complicated, and we modeled some of these and we were able to figure out the solutions, but now it's time to learn how to algebraically solve. And again, we're going to use inverse operations. Inverse operations, okay? That's what we're thinking all the time. So there's two things happening over here with this x. I see a plus 7, and I also see that it's being multiplied by 4. All right, the green and the blue stuff is the stuff that we really don't want to have over there with x, because if we can get x on one side of the balance, whatever's on the other side that equals x, that'll be our solution. And so just by following Mr. Gillum's directions, I'm going to say the first step I need to do is use addition or subtraction. And so what I see here is addition, and either the inverse of addition is subtraction. So the first thing I'm going to do is I'm going to subtract 7 from both sides of the equation. Okay, I'm not just subtracting it from this one term. I'm subtracting it like 4x plus 7 minus 7 equals 23 minus 7. Okay, now sometimes when the teachers teach that you just add it, you're adding opposites, you forget maybe that you're not just adding it to one term, you're adding it to the whole side. The whole side of the balance is getting added or subtracted to. So I'm going to subtract 7 from both sides of the balance here, or you can think of it this way if you'd like. And when I combine my like terms, that's where the 0 comes from. Or if you are doing it up and down, that's where the 0 comes from, and all that's left is the 4x. And on the right-hand side, if I have 23 constants and I take away 7 constants, I have 16 constants. And I still have some problems here because I have this 4 still stuck over here with this x. And now I've turned this equation into a one-step equation. The inverse of multiplication is division. So I'm going to divide both sides of the equation by 4. X equals 4. All right, and then of course checking your solution would be like this. I put those empty parentheses in where the variable used to be. And if I think the answer is 4, let's try to put a 4 in there. 16 plus 7 equals 23, or 23 equals 23. Okay, that's good. It becomes, it's balanced, so I know that that is actually the solution. Let's just pretend that we didn't know whether to add or subtract first, and then multiply or divide. Let's just pretend I divided first. So we'll start with the same thing, and this would be the incorrect way to do this. The problem with dividing, because this 4 is held together with multiplication, the problem with dividing both sides by 4 is that you don't just get to divide the part that you want, you have to divide the whole thing by 4. And so really what that would look like is every single thing gets divided by 4. And so what you're doing is you're creating a fraction here that you're going to have to use to solve. And so we can avoid that fraction if we add or subtract first. We could continue to do the problem and then subtract 7/4 from both sides. And there are strategies where we might need to multiply first, but we're not there quite yet. So again, you can do it that way, but then you're running into more fractions and those types of things. So my recommendation is always, if you can, avoid the fractions and add or subtract first and multiply and divide second. Okay. Let's take a look at these other two steppers. Again, there's two things here, subtracting of 3 and a division of 7. Let's do add and subtract first, and then we'll do division and multiplication. In this case, the inverse of subtracting 3 would be to add 3 to both sides of the equation, or the balance, and I know that opposites add to 0, so all that's left is y over 7. The subtracting of 3 and adding of 3 makes 0, and y over 7 plus 0 still equals y over 7, and that's equal to 7. Now I have division that I'm concerned with, that I do not want next to my variable anymore, and their inverse of division would be multiplication. So I'm going to multiply both sides by 7. When I say both sides, I mean both sides. So again, when I multiply fractions, the nice thing about multiplication is I can cross reduce, and that just leaves my y. On the right hand side, I get 49. Before I go on to the next example, let's take a look if I tried to do multiplication first instead of addition and subtraction. If I tried to eliminate that division with the inverse being multiplication, I would have to actually multiply that whole side by 7. And so it would be a distributive property. Again, the 7 over 1 times y over 7 would still get me the y, but then I would also have to take that 7 times minus 3, which would be minus 21, equals 28. And so if you want to try to avoid that distributive property, adding and subtracting is kind of going to be the best way to do the problem. If you do everything correctly, there is still the solution of 49, but if you follow addition, subtraction first, multiply, divide second, that's going to be the path of least resistance. Taking a look at this next one here, and again I want to do add, subtract first, multiply, divide second if I can. I'm going to start by using the inverse of addition. Subtract 6 from both sides. Alright, the opposites add to 0, and 8 minus 6 is 2. Then, of course, I have this division here, and I know the inverse of division is multiplication, so I will multiply both sides by 2. Okay? And so when I reduce, I have D on the left-hand side and 4 on the right-hand side. And I can always check my answer by substituting in the number I believe the answer to be. And if I think the answer is 4, that's what I'll put in for the variable. And so I see that 8 equals 8, which is a true statement, so I know that the equation is balanced. Let's take a look at these last two here. I see the first thing is addition that I don't want. But before I get too carried away, I want to make a point. Some of your equations might look like this instead. Just keep in mind that we're still trying to get the variable all alone, so we're not really concerned with anything on the other side. We're just looking at the side with the variable to determine what to do to both sides of the balance, okay? Because we're trying to eliminate everything near that variable. So it doesn't matter which side the variable is on this as far as the balance goes. Just look at that side with the variable to determine what to do next. In this case, we're going to use inverse operations and say that 2x equals 6. And if this is being held together with multiplication, the next thing I would like to do is the inverse of multiplication, which is division. X must equal 3. All right. And finally, this was one that I was talking about that's flipped around. Usually the variable's on the left-hand side, and if you prefer it there, you can just flip-flop the equals, the things on each side of the balance. But that would be the symmetric property, and we haven't really learned that yet. So I'm going to go ahead and do this, and don't get confused. Even though there's a 4 on this side, and we've been always subtracting and things from the left side, keep in mind this is what we're concerned with getting by itself. So I see an addition of 1 and a 3 times. So I'm going to start with my adding, subtracting first, multiplying, dividing second. So I see that the inverse of addition is subtraction. We'll subtract from both sides of the equality. 3 equals 3h. These are opposites and add up to 0. And so I have 3 times 3h. I'm going to divide by 3 on both sides. The inverse of multiplication is division. So when it's all said and done, all I have is h on one side, which is good because now I can see how much it's worth. And on this side, I just have a 1. So 1 equals h, or you can think of that as h equals 1. Okay. So that's it for today. It's solving two-step equations. If you make sure for today's assignment to add and subtract first, multiply and divide second, that'll be the best way to solve these. But there will come a time that we might want to multiply first strategically, but not today. So add, subtract first, multiply, divide second. Oh, I almost let this problem escape. Let's just go ahead and finish these up. I see the inverse of subtraction is addition, so I'll add to both sides. 10 equals 2k. The inverse of multiplication is division, so I will divide by 2. And all that's left to be done is to simplify. K equals 5. All right, there we go. Finish that up, and now we're done.